Okay, it says recording. Setting a timer. Got it. Okay. 9.5 minutes. Okay, we'll go. Okay, so chapter 4, and this is, I'm not going to get through all of chapter 4, but that's okay. Yeah, it'll be fine, right? Okay.
Let's do it all today.
Do it all today. Okay, so this is a little bit of applications of derivative stuff. That's coming off the screen there. Okay, so when they're talking about extrema on an, they're just talking about like kind of highs and lows. So if you think of a graph of a function, how it hits like a peaks and valleys type thing, that's what they're talking about when they're talking about this. Now, your graph could have many kinds of, depending on what your graph looks like, it could have a lot of peaks and valleys, but then you'll have a maximum, which is your highest point, and then you'll have your minimum, which is your lowest point. Oh, I need that button right there. Okay, so
So does extreme just mean the highest or lowest point?
Yeah. You can have like other extreme of low points, but then there's like a lowest and a highest point on here. They'll call it a maximum and minimum. Okay. So basically, on here, this is the critical numbers, finding these numbers on an interval. So I'm only talking about a piece of this graph. I'm not talking because, like a sine graph or whatever, those can go on forever. It's kind of narrowed down to an interval. So find these critical numbers. Just go through and find the first derivative. Set that first derivative equal to 0, because that is where your horizontal slope. So that would be like your highs and your lows if you're doing that. So that's why you take that first derivative equal to 0. And then you're just going to kind of test some points, and this is where you'd want a calculator to make it easier to plug stuff in. Okay.
If we have to test points, like we could plug in, like, does it equal 5? Is it actually 10?
I'll show you in a second. Okay, I'm kind of skipping through some stuff, so I'm not going to do every example, but when I went through this, I went through it after the fact. So, oh, I got to get out of here. Oh, God dang it. Okay. I know. It's like, wait a minute. Okay. So, what I'm going to do, you can just put this in example 2 spot, I guess. There was an example 1, but then it was something I didn't want to do. So, in the example 2 spot, we can put this one. Okay, so here's my first example, and it's on this interval. Okay, looking good, looking good.
So on interval, are those not the points?
No, between if like your x equal -1 to 2.
Oh, yeah, when it
It's-
passes through.
So you're looking at just a piece of this graph. This graph kind of does whatever. You're just looking at a piece of it. That's all you're looking at. So that's why they put it on an interval. Okay, so we're going to find the derivative. And this is an easy one because it's just a power rule one. So what would I have?
12x
12x
cubed minus 12x.
cubed minus 12x squared. We good there? Okay. Now, we're setting this equal to 0. So what do these two things have in common?
12x squared.
Okay, so if we take out a 12x squared, we're left with x minus 1, correct? Okay, so I got critical points that this one would be 0. Yes? If you set that equal to this, it just give you 0. Okay, and then this one would be 1. Okay, so basically what you're doing is you're you're going to just test these points, throw them back into the original. So if you plug -1 back into the original, and this will give you kind of your highs and lows, your maximum and minimum.
So why do you plug in both like the interval points and the points that will solve?
Because that's the beginning and the end of the piece. So you always use the endpoints too. Okay, so if I plug in -1, what do I get? It'd just be 3 plus 4.
Seven.
Hey. Well, the even power would make the negative go away. An odd power would change that out front. Okay, if I plug 0 in there.
Yeah.
I plug 1. It's what? -1. If I plug 2.
That's not-
It's a lot of math.
Mhm.
Oh, Lord. 16. Okay, so on just this interval, where x equals 1, that's a minimum because that hits the lowest. And then f of 2, that's where I'm going to hit my max. And that is just like I said, on a certain interval. It's not the whole graph because, just a piece of this graph. And that's all that is.
Really quickly, if you just draw the graph to show like everything. Or no?
If we type in the graph,
I guess so.
of what it looks like. You're making me get in here. Gizmos graphing. Graphing. Okay. And what do we have? Y equals 3x to the what? 4. Okay, I need out of there. Minus 4x cubed. It's 4x.
Ooh. Okay, so on this, it'd be, so at 1, it's at -1.
So here's that bottom of your graph.
And then at 2.
Then you
it's
go
all the way
2, it's all the way out there.
up. And then at -1, it's still 0.
At 0,
Oh, wait, oh yeah, it's at 7.
yeah.
Yeah, okay.
Okay, because this is kind of what the graph, well, it's like a touchdown kind of graph because number 1, your degree is 4. So it's going to look like that. And however many peaks and valleys are in there, it kind of looks like this. But that's what it kind of looks like. Okay, we're going to do, I don't need to go back to this, do I? Nope. Okay, let me go back to this. It says blah, blah, blah. It'll end in 2. What time are you at?
9.5 minutes.
You're 9.5? Okay. Okay.
So did you press like keep recording?
Yeah, it said in 2 minutes. So it must have at 8 minutes popped up and said in 2 minutes,
Oh,
it's
yeah.
going to shut off.
Did you press something else?
Yeah, I just said stay.
Okay.
Now we should be good.
Okay, we figured it out. At 8 minutes.
So 8 minutes, I get my warning. Got it. Oh, I just don't normally have to do this too much. Okay, let's look at, what was my second one? This one, you're gonna want a snow person. Oh, on. It's just talking about once around that circle if you're going from 0 to 2 pi. I'm saying this for him.
They are actually, we did.
Oh, you good?
We definitely didn't eat grass.
Definitely didn't. The other day when I went to Jimmy John's, one of my old kids works there. And so I got my meal and I go, hey, we'll see you later. And he took one of the brownies and threw it in there. And I'm like, oh, you're too kind. Oh, it was good too. That brownie was good. For Jimmy John's, that wasn't bad. Okay. I was kind of.
We had a guy come in the restaurant the other night and just buy 10 brownies and leave.
My man, there you go.
He's like, you just made those, right? I'm like, yeah, they're like from yesterday. He's like, yep, I'll take 10.
Okay.
Well, actually, he goes, how many are there? We go 14. He goes, I'll take 10. I'm like, why don't you just get all 14? They're $1 a piece, right? No,
Did he get any ice cream to go with him?
No. He got a
I would think get us some ice cream to go with him.
He got a brown paper bag full of brownies.
Nice. Nice. Okay, derivative of the first part of this.
2 cos x.
Okay.
And then I forgot to put to you when it's like, the cos is 2x.
So it would,
Times 2.
it'd be a negative sine 2x, which would turn this into a plus. Okay, we good there? And then, what's the derivative of this? I'm just going to dump that right there. Put it in front, not behind it there. So it's kind of like derivative of that and then the derivative of stuff. Okay. Okay. Now, I suppose you don't have that in front of you. You have your snowman in front of you. What's on your snowman? You do not have your snowman in front of you?
Not yet.
Not yet. Only because I'm looking at this right here. I'm looking at that double angle because you have a sine 2x in there. Okay, so what I'm going to do is I'm just going to substitute so because your snow person has the other stuff on the back, right? Yeah. Okay. Because back here on this, that's not really going to do anything for me to get, I can factor out a 2, and that would be all I can do here. So to get rid of that sine 2x, substitute in that double identity where it was, so this thing right here, I just changed into that. Are we good there? Yes, yes. Okay, now what do this and this whole thing have in common? There's a 2 and a cos. All right, so I'm going to take that out. And then that leaves me with a 1 right there. If I take out a 2 cos, I'm left with 2 sine. We good there? Okay, good. All right, now I'm just going to set these two things Because now you're taking it and setting it equal to 0. Okay. Because this one couldn't do because of that doubling, but we can change it. Okay. So this would just be cos equals 0, right? Because if you divide by 2, that's just where you're at. This one, are we good with negative 1/2? Okay. So, where's cosine 0? Right where?
Oh wait, when we do this, is it, I always forget, is it where the angle is 0 or where is it like, that's,
Where that.
so it'd be 90 degrees and 270 degrees.
So we're at pi over 2, 3 pi over 2. Where is sine negative 1/2?
7 pi over 6. What about pi over 6?
And then this is kind of my interval. I know those aren't in order because this one would go before this one, but.
This is dumb, because the minimum and maximum will always be 0 and 2 pi. Like you find the minimum and maximum.
You throw this back into here.
Oh yeah, that's right.
But remember, when you're throwing these back into here, remember, they'll give you like 1 zeros, 1 cent. They'll give you a good number to work with. So if you plug 0 in there, what do you get?
We're plugging 0 for what again? X.
Yep. What's sine of 0?
Okay. Sine of 0 is still 0.
It's still 0, so all of that is 0. If I put a 0 in there, that'd make this 0. So what's cosine of 0? 1. So what's 0 minus 1?
-1. I don't like this.
Keep going. Come on, kids.
Okay, the next one it'd be 2 minus, and then I don't know. What do you put? What do you multiply the 1/2 times 2 first? Or does
Are you
it-
putting in pi over 2?
Yeah.
So the 2's cancel out.
So just be pi.
Yeah.
And that'd be -1. So it'd be
So you said 2 minus negative 1, which would be?
Would it matter if you found 1/2 and then multiply that by 2? Because that'd be 0 times 2. Like going off of your snowman, if you plugged in.
Oh, I just on this one, because it's double angle, it's a little,
So you do it on the paper first, not on the snowman.
I usually do it that way.
Okay.
But you can do whatever.
You can. Because if you do it the other way, you get 0 times 2, which is 0.
Oh, true. Yeah. You can type it into a calculator too. You'd have to be in radians though. Since you're doing stuff in radians. So you can plug those numbers in right there and type them in.
Would that be easier?
Okay. Try it out. Try it out. Oh yeah, you gotta change it though. I have some orange mints. Oh, I actually have some mints from testing stuff. If you want to try some of those. Okay.
Is the third one negative 1/2, or negative 1.5?
I got -1.
What do I have on my thing? I have negative 1.5
That's what I got.
on my answer thing.
I don't like doing that, but I don't like doing it anyway, so.
Well, then there's that. Um,
Okay, so for the fourth one, we're doing cos 2x. You have 7 pi over 6. What do you do? 14 pi over 6. What would you do?
which one are you looking at?
For 7 pi over 6.
7 pi over 6.
And how it's the double angle.
Oh,
Is that another calculator problem?
you might want to do a calculator on that one. You might want to do a calculator on that one. I don't know how much time has gone by. No, it's still good.
So I don't know what's the proper way to do, like, where to enter in the pi. Actually,
Where to enter in the pi.
so like for this. We do like 7 pi over 6.
I'll just do 7 pi over 6.
Okay, now I got -1.5.
For
This one?
the 7 pi over 6, or which one are we looking at?
Yeah, 7 pi over 6.
You got a what?
-1.5.
Yeah, that's fine.
Okay, yeah. Oh, I have them in a different order on my thing than they have them right there. Okay. Ouch.
Is 7 pi over 6 also negative 1.5?
7 pi over 7 pi over 6. Yeah.
Is 11 pi over 6 also? That's mine. -1.5?
They got negative 1.5 on 7 pi over 6 and 11 pi over 6.
What's 3 pi over 2 then?
Negative 1.
Oh, I believe negative 1.5.
Oh, Mine were written in a different order up there, so I was just looking at the answers and no. That
Oh, so
one
I
should
did
be
get the
negative
right
one.
answer. Okay.
That should be negative one. Sorry, I had them written differently because I put them in order. Like I put 0 pi over 2, 7 pi over, and so mine were out of whack when I did some stuff in there. So yeah, it's like, yeah, negative 1.5, but if you were putting in that, no, you got negative.
And then 2 pi should be the, oh, never mind.
I
Never mind.
got a negative 1 for 2 pi. Calculators.
Well, on that one, especially when they give you something like, you know,
Can you show us what this graph looks like?
let's go back out here. Let's go here. Okay, so we're doing, okay, what is it? 2?
Sine x minus cos 2x.
Cos 2. Oh. Oh.
Great.
That
This is a lot of work for just one problem.
that's an interesting looking one. Huh. Huh. Okay, so if you're looking on an interval, because this, when you do Desmos, it's in radians. You have to change it in order to get out of that. But if you're going 0 and figure 2 pi is 6 point something, so you're kind of in here. So there was your max. And this one, you have to have 2 minimums on that one. It's a funky graph. Okay, that's all I got for the first section. And I cut out a couple examples. Told you, bare bones in this one. Okay.